everyone. I am Liz England. I am a team lead game designer at Ubisoft Toronto. I'm here with Chris Dragert, who is a team lead game systems programmer. And together we're here to talk to you about populating London, the systems behind Play as Anyone in Watch Dogs Legion. Now, first and foremost, Legion at its core is a game about people. And from the first phase of conception on the game, sort of like our main pillar was this concept of play as anyone. And this meant that you could recruit any character in the open world that you could find and you could encounter, and you recruit them onto your team and then be able to play as them. And that also means that characters that are normally background NPCs in most open world games now need to be handled with a lot more depth and a lot more care in order to sort of reward this sort of recruitment system and gameplay. And then on top of that, Census is our internal name for the systems that drive play as anyone. So for a brief overview of this talk, we're going to be covering character profiles, which are the data that goes into generating all the individual characters you find in the game. Scheduling and persistent, which is sort of like our main simulation layer. Upresing, which Chris is going to go into a bunch of detail later. And affinity and memories, which drives our recruitment loop, and it's sort of the interaction layer for the player. This is where the player gets to actually interact with these systems. Now, Chris and I are going to be handing this presentation off back and forth, where I'm going to be covering design and direction of these systems and some of the why behind them, and Chris is going to be covering them on sort of like the how from a technical perspective. And I'll let Chris introduce that real quick.
Hi, everyone. So a big system like this has a lot of high-level requirements, and in my portions of the talk, I'm going to make sure that I kind of go through and address these points. So the first big requirement is that the London of Watch Dogs Legion is massive. This means that we can't use tricks like pre-baking or scripting the population. We really need to have some kind of procedural generation to make this work. On top of that, the census system, it needs to generate a wide variety of characters that are consistent, not just internally consistent, but also with their role in the game world and their appearance. We also need to make sure that these characters are simulated. Because players need to be able to interact with them. They need to meet them over time. So on top of simulation, they have to be persistent. And then at the end of the day, we're still making a video game. So that means we have to hit our strict performance and memory budgets, and Census has to respect all those. I'll throw it back to Liz.
Right, so I'm going to start us off with character profiles from the design point of view. Now, when we're talking about something like play as anyone, what we're really talking about is on design side, and when it comes to census, is who are we populating our world with? And then what kind of data makes up a person? So when we're talking about who we put in our world, from a design point of view, the first thing we're really looking at is the diversity of London. It's a major multicultural city. It's the main setting for our game. So we need to look at demographic data for the city. These are things like the ethnic breakdown, the major types of employment, income brackets, so on and so forth. Then we take a step further in and we look at different kind of subcultures throughout London. So what kind of communities exist and what types of people might you find in those communities? And we don't stop there. We continue on and we start looking at individual stories of Londoners, and we use that as inspiration for our data, because what we're trying to do is generate individuals, not just generic populations. And this sort of tiered approach allows us to take into account both broad trends and the smallest of details. And then we're not just generating people in modern day London, we're also really looking at our dystopian version of London. So our system that needs to be able to handle generating a normal population, we're also looking at a lot of data in terms of like, how do we generate paramilitary forces, organized crime, tech and automation jobs, unemployment, immigrant groups, protest movements, so on and so forth. These are all very thematically related to the game. And next, we also want to be able to generate ideal fantasy characters of a DedSec resistance group. So these are hackers, vigilantes, spies, activists. These are the types of characters that you might want to have on your group. They're also the types of characters that players may have encountered in the first two Watch Dogs games, and they're part of our brand. And then last but not least, when we're talking about the people, we also want to make sure players can find themselves or someone like them in the game and be able to recruit them onto their team if they want. So this meant casting a really wide net for all the different types of people we might want to be able to generate with the same system across the board. And then this also meant that we wanted to do a little extra special attention to underrepresented groups. So these are people that play games, that play our games, but they often don't see themselves represented as the main protagonist in a AAA game. And then I just want to highlight the sheer amount of work that's being done, because it's not just up to the census team to say who the characters in our game are. It's really a team-wide mandate, and everybody was tasked to work on what play as anyone meant across the entire project. And so as everybody was doing their own art concepts and deep dives into who are the people of London, who are you playing as, all this sort of qualitative work was then shared with the census team, and we took this information, we started to break it down into concrete pieces of data to feed into our generative system. So when we're talking about breaking someone down into data, some of this is pretty straightforward. So we have gender, age, ethnicity, we're all familiar with those, what types of clothes a person wear, but also like what is their occupation, but not just what's their occupation, what is the set of occupations we want to try to represent in our game? And what is a person's personality? So if you go up and you insult them on the street, how do they react? And so on and so forth. So we have all these different types of data that we use to try to determine what makes up a person. And every character in our game can be represented by this data. And about halfway through development, I would say we had a fairly good, large, varied set of characters populating our world. We had locked down most of this data. We knew what we were trying to create. And two things were pretty clear at this point. One was that Census was working. We were generating characters and that they were internally consistent. But at the same time, those characters were just okay. They weren't particularly memorable. They didn't really stand out. They especially didn't stand out as trying to create characters that could fulfill that sort of fantasy role of a AAA game protagonist. So we shifted gears a little bit and we did another focus. What we tried to do is identify a number of different fantasy archetypes. So these are types of characters that we might want to be able to find in the game, and they fulfill some kind of player fantasy. And we did a few dozen of these, and we did one-page design directions for a lot of them. And we were not really trying to pay much attention to the specific pieces of data. What we're actually looking for are these sort of aspirational, sort of descriptive dossiers on these characters as though they were completely authored and not paying attention to sense at all. And so that we can create these sort of ideal versions of a character and then bring those ideal versions back to Census and turn them into test cases. So we can ask questions like, can we generate a football hooligan? Can we generate a drone expert? Can we generate a little old British grandmother who can hack? Eventually the answer was yes. But this whole process of comparing fantasy archetypes with census data was really important to bridge the gap between having just a sheer ton of data and then knowing exactly how we wanted to organize that data and what we wanted out of it. So we could take each of the fantasy archetypes and ask what census data is needed to generate this character. So in this case, with the hacker grandma, the most important things are that she's old, that she has a specific kind of voice, that she wears a certain kind of fashion, that she has this low mobility animation style. We actually don't even care what her occupation is because she could be a pensioner or a librarian or anything as long as it matches someone who's sort of old. But a different fantasy archetype like the spy, their occupation is actually core to this sort of like fantasy archetype of who you're playing as. It's the spy. So when we do this exercise for fantasy archetypes, we can start asking a few questions out of Census. So the first question is just, does Census even have the data to generate this kind of character? Can I generate a British spy with the data that we have in Census? And if the answer to that is no, then we have to go back to the data and start changing it, start filling in the gaps, figuring out how we can make it so that this character is even possible to spawn in our system. Once we can confirm that, yes, we can generate a British spy, then we can sit down and say, well, I'm going to generate 100 British spies, and then I'm going to compare them against each other. To solve, I need to answer kind of two questions. And one of these questions is, if I put two characters from this one set of 100 side by side, do they show rich, meaningful variation? Are there reasons players might choose some spies over the other? And at the same time, we're also looking at, if I look at all these spies together, do they all read properly as a British spy fantasy? And this is how we ended up with characters that are consistent with sort of the set of expectations. These are all British spies. They have certain properties, certain looks associated with a British spy. But again, enough variety to satisfy a player's expectations that they're individual characters and that there might be reasons to recruit one British spy over a different one. And then real quick, I just want to go over a couple of the properties we avoided putting into the census data profiles. At this stage, we wanted to avoid overly broad fields. So for example, determining that someone's high class or low class. There's no real consensus on what high class means. It's a highly subjective term, and instead we found it far more useful to just use a combination of properties that were much smaller and more specific. So if we wanted to represent someone who's high class, we wouldn't put high class in the census, but we might put, okay, the combination of someone's income, their job, their fashion, and their voice might signify someone being as high class. And then we also tried to avoid overly restricted data. So all X or Y, no X or Y. This creates repeats or clones. There's no meaningful variation between characters in the set. They don't feel like individuals. This is where I generate 100 British spies, and every single one of them is identical to the other one. There's no real differences between them. And then the last thing that we tried to avoid was propagating unnecessary real-world bias into our systems if there's no real purpose for it. So a real simple common example might be gender and occupation are statistically correlated in the real world, but we don't really gain anything of value if we make most of the hackers in our game male, even if that represents the real world, because if I'm as a player want to go recruit a female hacker, now I have a worse experience. So the key here was that our characters were believable, and not necessarily that they represented a perfect demographic statistical breakdown of the real world just for the sake of realism. So with that, on the design side, I'm going to kick it off to Chris to talk about the tech.
Yeah, so behind the scenes, these characters are represented with what we call the character profile. So this is where we contain all of the different values for all the different demographic fields that actually define what one of these characters are in our game. Here we can see the graph. This is what we actually shipped with. These are all of the different character fields that are represented. The big thing to note here is that you can see a lot of the fields are actually connected to each other. All of those connections are bidirectional. So if I zoom in on voice, voice, for instance, you can see it's connected to gender. And what does that tell us? Our choice of gender influences our choice of voice. Our choice of voice influences our choice of gender. They're bidirectional. But let's say I'm actually trying to make a character. So let's say in that field of voice, I choose, voice for the cunning grandmother. Well, this actually has an impact on the other fields. So to make a character that's consistent, it's important that we make consistent choices across those connections. So in the age range field, now that I've chosen the voice for an elderly woman, it's important that I assign an age range that makes sense. So rather than making them young or middle-aged, it's important to make them old so that the system is consistent. And then this process just repeats. So going from age range, now that I have someone who's old, it limits the types of occupations they might have. So they could be a pensioner, a retiree, maybe they're a partner at a law firm. And then the process just continues. So if we look at the next field, income, obviously a pensioner is going to have a very different income than a law partner. So then creating a proper character is a process of filling out this entire profile and selecting everything, selecting a value for every field. Just to give you an idea of sort of how they're related, I'm going to drill down into a really, really specific type of relation here. So right now I'm looking at occupation. The occupation field is linked to age range and fashion. Here we're looking at one particular occupation, which is accountant. Accountants can have a variety of age ranges. They can be young, middle-aged, adult, or old. However, a young accountant is allowed a certain set of fashion choices, so they can wear business casual or business formal. On the flip side, an old accountant can wear business traditional and business formal, but an old accountant cannot wear business casual, and a young accountant cannot wear business traditional. Right? This is just a way of, at a very, very micro level, allowing us to create consistency between the character, how they're presented in the game, and what their profile actually contains. So this process, this is actually called the field relation table. The size of this table, the number of rows in one of these is actually just the size of each of the fields that are connected multiplied together. So as the number of fields that are connected grows, or as the size of an individual field grows, then the relation table can get quite huge. In practice, we had to limit it. We had a maximum of 4 linked fields, and that allowed us to constrain the relation table size. Even then, some specific fields, such as occupation, were limited to just 2 links. The reason this was necessary is that every single line of this was hand-tuned, And if we had, 100,000 or 1,000,000 different relations, it'd be completely impossible to actually tune and configure that. And as well, the performance would take a big hit. Now, to actually do this in practice, the technique we used was something called the flood fill algorithm. So again, I'll drill down into the occupation field. So here we can see we have a set of occupations. There's a bias assigned to each one of those. So when we're selecting one, we're choosing which ones we want to see more or less in the game. So let's say we roll the dice and choose Albion Contractor. Now, the occupation field is linked to age range. And Albion Contractor, we can look at that one and see that the only defined relations are for adult and middle age. Now, what does that mean? It means that young and old are not valid choices. If we picked a young Albion Contractor or an old one, we'd have an inconsistent character. So the way the flood fill works is that we actually remove those values downstream. So we get rid of young, we get rid of old, and then we just keep propagating this. So that if there's any relations, if there's any fields connected to age range, we remove any relations that are only present for young or old, and that ensures consistency down the line. Now, when we go through this process, if we ever hit a field that has all of its values removed, that's something that was an anomaly. That was essentially a data error based upon either the predefined fields coming in or how the fields were connected. So we had to develop a lot of debug, and we had to pay a lot of attention towards making sure we spotted anomalies and corrected them in data so that everything would spawn as expected in the game. As part of this process, one thing that really helped us to use the fixed ordering for the full refinement. So we always knew the fields, the order in which the fields were being selected. That allowed us to calculate conditional probability going down. It also allowed a really big crutch for debugging because we at least had an idea of how these choices were being made. Performance-wise, at the beginning we used the SQLite. This is basically for prototyping. Now, at the very early phase of this, we had something like 10 fields, and there were relatively few field entries, but full refinement took 6 milliseconds per character. That was on the PS4. So obviously that's not going to scale. It's not shippable. It's far too slow. So the engine team really came through with a custom bit field representation, because essentially what we have is a relational database. But there's a lot of things we don't have to do. We don't ever actually modify the data at runtime. All we do is read and join. So each census field we can represent in memory as a bit field, as large. Sometimes they're as large as 1200 bits, and that tells us the allowed values for that specific character. So that means a relation table is actually just a combination of the bit fields for two different fields. And the way we define the relations is using a multi-dimensional bit matrix. So if the bit for a specific dimension, if it's set to 1, then that tells us the relation exists. If it's 0, then there's no relation. That means we can actually rely on that. Our flood filling operation then reduces to just a series of AND operations between bit fields. So sort of the complexity disappears on the sort of at the low level, and we can just do a bunch of AND operations to figure out what our characters look like. Just to take it a step further, all of our bit fields they get statically allocated at launch during initialization. So we can take advantage of cache locality. We don't have any cache misses during these operations. There's no dynamic allocations. And this made a massive difference for performance. So in the actual shipped game, we had a total of 19 fields with 919 values defined across them, not including the thousands of names and surnames. There were 18,825 relations defined between these values. That allowed us to generate tens of millions of unique, consistent character profiles. And that's just the character profile. There's a lot of census data outside of these profiles that blows that number up many orders of magnitude, but just the character profiles were already in tens of millions. And the full refinement for one takes about 0.6 milliseconds on average. So what worked well for Census was trusting the system, especially sort of in the middle of the project when we were preparing for big demos like E3 and stuff like that. There was a really strong temptation to make perfect characters where we defined many fields across Census, but that actually had its drawbacks. We found that led to the problem where every single spy felt identical, and it didn't allow variety to thrive within the game. Instead, by pulling back a bit, by finding the specific fields that were most important and tuning based upon those values, the system could generate characters that had that variety, but still met the game requirements and the demo requirements. Now, even then, performance was still a big concern, even with our bit field representation. Throughout development, new features would sometimes necessitate adding new fields. We might have to change the relations because we weren't getting the combinations that we wanted. And these would all have an impact. They would either, just directly increase the number of fields or increase the size of the relation tables. So we constantly had to tune these and prune them and rearrange how fields were connected to get to something that really worked. And then one final note, flood fill, we found that could pigeonhole refinement. So a good example of this at Alpha, we actually found that about 20% of the people in the world were pro football players. Obviously, this is pretty simple, and that wasn't what the data was supposed to be doing. But we actually found that we were sort of naively choosing the age range, and a lot of people were getting young. And every single person who was getting age range young, it turns out there was only one occupation available if they happened to get high or very high income levels, and that was pro footballer. So we found that just the flood fill process kept pushing us into that same choice, and we ended up with statistically poor results. So we really had to pay attention to that and make sure that we had enough choices so that flood fill was never pushing us into the same corner. With that, I will throw it back to Liz.
All right, thank you. So I'm going to introduce you to the scheduling and persistence topic. So scheduled activities on the design side is fairly straightforward. So we split people up into a 24-hour schedule and then assign activities to these slots in that schedule that are between 1 and 4 hours or so long. Chris is going to cover a bunch of the technical details, and I just want to talk about some of the design considerations we had when we were deciding what activities are populating our world and what activities any individual person does. So we're talking about the activities that populate the world. Some of this is pretty obvious. So the most obvious and the first requirement is really just visible animation assets that the player would physically run into, be able to see on the street. So in other games, the NPC that's protesting, this could just be background sort of aesthetics or mood, but like in Legion, like these characters needed to become real, right? The fact that they're protesting had to be part of their identity. It had to be integrated into the system. It had to be consistent with who they were as a character. Next, we're also just like looking at general everyday activities, so people's work activities or their rest activities. So every one of our several hundred occupations has an appropriate location or multiple locations where they can go work, the activities that they do for their job. And as often as possible, we try to take these activities and put them outside so they're viewable by the player and they can see them do that work activity. But many of them, like sleeping or rest, that's just going to exist behind a door in a building, which leads me to the next topic, which is buildings. So activities are also tied to locations, and when a location has visible branding, we want to make sure that the people going in and out of this location have valid reasons to be there. Anyone entering or exiting a bakery in our game does in fact have a reason. They're either the baker or they're there buying food. So the same is true for law firms or nightclubs or banks or travel agency or laundromats and so on and so forth for all the different types of locations we have in the game. And then last, we also fill up a character's remaining hours with a number of different sort of leisure activities. And here we have a lot of leeway to add narrative flavor and sort of try to represent different kinds of personalities. So for example, we might have someone reading at Piccadilly Circus until 11, like here. But whenever possible, we actually try to show you something a little bit more specific to that character. So you might find someone who's reading science fiction or self-help or mysteries or romance novels. Again, that's all tied to the type of person they are. And when we're deciding which activities a person has, it's based off of their census data. So that profile data that we talked about earlier, things like your occupation, but also your fashion, your age, your cultural background. We use this in order to give somebody an appropriate activity or set of activities that are consistent with the rest of their character and that they're informed by sort of their background. So that's why you're more likely to find, if you profile an old person, you might find that they're going to go knitting or play bingo at a retirement home. And if you look at students, they're often going to go partying or attending class or seeing a show and so on. Next, we also have relationships. So this is our way of building a social web between different characters in our game. And when we're talking about the relationships, there's a few basic different types of relationships that we cover. So we have family relationships. This is your mother, your father, brother, grandmother, husband, and so on. We also have positive relationships. So someone that you might care about, but is not direct family. So friends, cousins, classmates, colleagues. Transactional relationships. Those are usually some sort of business arrangement. A lawyer has a client, a drug dealer has a customer, a police constable might have an informant. Rivalries are sort of relationships where the two people hate each other. So a harasser and their victim, or a loan shark and their debtor, a hitman and their target. We also have, if you find a politician, they might have a political rival, which is another politician that they hate each other. So again, we use census tags, we use our census profile data to help cast people into appropriate roles for all these different types of relationships. And then when we're trying to define what activities that two people in a relationship can do together, it's actually pretty simple. We just look at the relationship and then we look at our set of all the activities in the game and we do a simple whitelist to determine which activities make sense for this pair relationship to have. So if a grandmother and her grandchild are scheduled to meet, you might find them go drinking tea outside of a shop, but you're not likely to find a loan shark and their debtor sitting down together to have tea. So now it's up to Chris to talk about the tech.
So as Liz indicated in the introduction, scheduling really forms the basis of the simulation layer. So, a schedule at its core is a very simple thing, right? It answers two questions. It says, what is the character doing right now? What should they do the rest of the day? In this case, we can see Jacqueline here is protesting at Parliament Square Gardens until 11. So in order for a schedule to be meaningful, it really has to be combined with persistence. And persistent characters are the heart of Watch Dogs Legion. Persistence relies on scheduling. Without a schedule that was telling us where they should be or what they should be doing, persistence wouldn't really make sense. And without persistence, having a schedule wouldn't make any sense. So the great thing is that scheduling tells us where the character should be at all times. So we don't actually have to execute any fancy AI logic when they're despawned. And the position is then kept up to date by our persistent entity manager. And then there's a lot of things that sort of come quite straightforward. If a character ever crosses the player's loading bubble, well, then that character should be spawning. They might be spawning, walking to their next appointment, or if you're passing by the pub, they might be spawning in there, meeting their friend for a drink. Census data, it's all handled outside of the entity component model. So whenever a persistent entity respawns, we always sort of reattach that census data so that there's continuity between spawns for that character. All of our schedules are dynamically generated. This is necessitated by the fact that London is so big and there's so many different people in it. All the different character profiles, we can't possibly hope to pre-baked schedules that are going to, match all of the different profiles combined with all the different roles and all the different things they could be doing in the game. So we dynamically generate it. It's sort of a three-step process where we determine their current activity and make sure they're scheduled to be doing it. We determine what other activities the character might like to do, and then we find places for the character to perform those activities. So this allows us to provide schedules on a just-in-time basis. We don't need to, pre-bake or pre-compute anything. When someone needs a schedule, we can provide it precisely at the moment that the player shows an interest in that character. So the first step is sort of alibi generation. Who are you and what are you doing there, right? So our friend Davey here, we can see that he's having a beer with his friend. And then if we look and we read what they're doing, it says partying with Marianne Middlebrook. So what we're really doing here is justifying the NPC's current activity. This brings up a really important rule. And it's that the schedule should never, ever contradict the visible actions of an NPC. In a game, in an open world game, it's very rare that you would put in text on the screen exactly what that character is doing, because there's the chance for dissonance, right? If you put the wrong thing up there, then the animation may not correspond and it could easily sort of break down. So our very first level was to make sure that what they were doing, what they were visibly doing, was always justified and reinforced by their current activity. Now, to choose these activities, we actually sort of behind the scenes, we have a concept called contracts. And contracts are gated by the character profile. Now, the data was set up in a very clean way. So a person with the occupation window washer in their census profile becomes eligible for the contract work.window washer. Similarly, a person with middle class income becomes eligible for rest.middle class housing. So that tells us what kind of contracts they have and therefore what activities they should be doing in the world. Leisure activities can be a lot more flavorful. So here we might look at lesser used parts of their profile field. We might determine that a tech expert can receive leisure.drone piloting, or a fitness buff might receive leisure.fitness. On average, a character receives 1 work, 1 rest, and about 4 leisure contracts, give or take. Now, some of these contracts are what we call relation contracts. So here we actually use special contracts that have 2 participants. So examples of relation contracts might be, marriage or a sibling or colleagues, things like that. When assigning relations, we have the ability to use the contract to dynamically create the person at the other end, because it's not always the case that when you profile someone in the world, you actually see the other person, right? So we can dynamically create them. And here we use what we call dynamic profile constraints. So it's important that, for instance, siblings share the same ethnicity, or a parent is older than a child. Now, the exact values aren't important. That's sort of the dynamic aspect of this. As long as the parent is old and the child is middle-aged, or the parent is middle-aged and the child is young, well, it's consistent and it works, but the exact values are unimportant. Now, another important thing in our game is that we want to make sure all of this is realized. We don't just want to have our sort of relationships be defined by a line of text on the screen. It's not very interesting. So we want to make sure that all of this is visible and performed in the world. So if we have best friends, siblings, or colleagues, well, they're all able to perform the leisure.drinking activities. So we actually want to see it. We want to schedule that at the local pub. And if you happen to go there at that time, you'll see them sitting down together doing an animation where they're having a beer. You can see romantic partners go on dates and perform different actions that make sense given the context of their relationship. Now, part of this is actually the simulation, what we call schedule following, having a character make it around the world and go to all their activities. Pretty early on, we decided that this was not going to be the emphasis of the game. Following people is kind of boring and it's a little bit creepy, to be honest. But we still had a baseline simulation goal, which was to make sure that what we promised in the schedule is what those characters did in the world. We needed to ensure that they could successfully move between their activities. To do this, we had characters either walk if the distances were short, or they could take the tube, which let them walk into a subway station and then despawn. And then once they despawned, it allowed us to kind of use traditional AI techniques. So things like teleporting them across the city, lerping them between locations. It really made it a lot more simpler, and it also gave us the ability to sort of guarantee a despawn character was always going to be in the right spot. So we could always put them at the exact location or traveling between them, depending on what their schedule indicated they should be doing. Overall, we had about a 90% success rate in reaching their next activity on time. Some small subset of people would occasionally be late, but overall, the simulation layer was pretty solid. Now, because there's sort of this shortcoming where it's not very interesting to actually kind of go through and follow their schedule, it necessitated adding a feature called the Deep Profiler. So this one's really interesting because it provides a direct player-facing view of this dynamically generated schedule. So for instance, Jacqueline here, you can see they act as a consultant at Boxtown. They go and protest at Parliament Square Gardens. They volunteer in Westminster. So you can really get this view of who this person is and what they do. And furthermore, you can actually place a waypoint to investigate any of these specific scheduled activities, which sort of puts a marker in the world, and you can go to that location. And in fact, we even throw up a prompt that allows you to fast forward time until the exact moment that person appears, which lets you easily go and see what they're doing and see what that activity is all about. So then overall, scheduling it's a very data heavy system where we're talking the tens of thousands of activities in the world. But luckily, it's never the situation that we need to generate someone's schedule that same frame. Scheduling never requires immediacy. That allows us to aggressively time slice and spread work across many frames. Even still, requests often took far too long to compute. It took 2 to 3 seconds. This would actually delay the profiler appearing. So that 2 to 3 seconds actually had a player-facing impact. So to solve this problem, we had to use aggressive caching. So we have something like 38 megs of schedule queries that are all cached and just sitting in memory ready for us to use to generate schedules. So we can quickly look up various scheduled activities, and it reduced the performance cost dramatically to less than 1 second. Because we had all this stuff cached, we could actually spend a little bit of extra time to try to find the best activity. For instance, we could optimize for being visible in the world because something where you can see the person in the world is more interesting than something that happens behind closed doors. We could optimize for scheduled locality, which means that their scheduled activities were somewhat close to each other instead of ping-ponging across the city, and so on. We had a bunch of different fields here that we tried to optimize across. Even so, it was still extremely data dependent. Some activities could be done at 10 locations, others could be done at 10,000. So this was very much a case where we had to optimize for the worst case. So what worked well for scheduling was despawned activities. Putting an activity in the world means recording mocap, marking up the data, actually treating that animation, cleaning it up, the LD work, there's really a long run up to putting this stuff in the world. However, putting a despawned activity in the door is much simpler in comparison. So using despawned activities allowed us to sort of switch on scheduling very early in development. This meant that we could really debug and validate the system at an early stage without necessarily being blocked by the world teams to properly place everything. Which meant that we could really put the game on a firm foundation. Mission dependencies, they did require a lot of stability and predictability, perhaps before the system was able to provide that. So we addressed that by introducing a lot of special logic, including 24-hour activities, I should say. This sort of felt like a questionable thing to do at first, but we actually found there were a lot of reasons in the world that they were justified. For instance, a mission would call for someone to be a hostage that you had to go and rescue. It didn't make any sense for them to be a hostage from 1 to 2 p.m. and travel on their schedule the rest of the day. So having 24-hour attendances in that case actually worked really well. And then it actually provided a ton of predictability. So whenever you went to sort of perform your mission and to do that beat, the characters are always there doing the right thing. So the 24-hour activities actually ended up being very, very essential to shipping a solid game. Now, one of the more complex cases was handling guards and combat units. If guards followed schedules, a player could just hang around till 4 p.m. and all the guards go off shift and just abandon the layout. Well, all the LD patterns are going to be broken. The mission difficulties, going to be non-existent. So then we really had to make sure that we provided that consistent experience and add in a lot of special cases so that the guards and combat units behave predictably, and the LD team could set things up in a reliable manner. So up next is upresing. Upresing is a really, really important piece of the puzzle, and it actually sort of it starts to bring things together in a player-facing way. So upresing is essentially our LOD system for Census, our level of detail, and it's a number of stages, and we sort of advance characters through that upres process. So everything I've talked about so far, so the profiles, the schedule, all of that, we call those Census operations. So all the different things we do in Census are actually encapsulated within operations. So things like profile refinement, schedule generation, and so on. Operations require significant computational resources. So by having a staged upres process, we can then control when and where we spend these resources by deferring the expensive operations. Characters themselves, we can then upres on a just-in-time basis and provide what we need at the exact moment that the player needs it. So all of the operations manager flow through, or all of the operations flow through a central operations manager. Having a single point for operations allows us to do things like lock NPCs. so that we can be sure that no operations are conflicting with each other. We can prioritize operations so that if a player initiates an operation through one of their actions, that's going to complete faster than some background process. And as well, it provides us a single choke point to replicate the results. And in addition, every operation can be time sliced. And then as that's happening, we allow for a custom callback registration so that the second or like the exact moment that that operation finishes, we can then tell the caller that it's complete and here are the results and go do whatever you needed to do without any busy waiting or polling or anything like that. So in the beginning, every single person that spawns in the world is what we call stage 0. So to create one of these stage 0 characters, we have to sort of respect the engine architecture, which requires that spawning tasks resolve in a single frame. And then as well, we have to consider the fact that any field can be constrained in data in any order before a refinement. So some specific animation in the world could put down a bunch of random data points to create a consistent character for that animation, and they could hit fields all across Census. So the big solution here is that we only perform a partial profile refinement at stage 0. We don't upres the entire character. And in fact, we limit the fields to just the player-facing ones. So we'll do things like the age and the fashion, because these are things that you can see just by visually examining that character in the world. We might refine their voice initially because they might need to have a line of dialogue in their animation. Overall, it's a significant gain. It can reduce spawn costs for partial refinement by 20 to 80%, depending on the fields coming through. So overall, this brings the cost for refinement closer to like 0.1 milliseconds, which is a huge gain and allows us to actually fit this important step in the spawning pipeline. Now, let's say the player sees this person walking down the street and says, hey, they're kind of interesting. I'm curious to know more about them, and they go to profile them. Well, at that moment, we kick off the stage 1 upres. So here we perform the full profile refinement. We now get all of their demographic fields and sort of figure out who this person is in full. We dynamically create their schedule, and that allows us to make the character persistent. As well, we add in additional bio information. So this is stuff like their name, their precise age and income, the trait information to show in the profiler. So now we can provide all this information, and then the player can really see who this character is. The next step is the player deciding, you know what, this person's really interesting. I think maybe I might want to recruit this person. So they decide, you know what, I'm going to save them to my team app as a potential recruit and then look at them later. So now we have a whole bunch more information that we need to fill in. So here we actually go through and we start adding their relations. So we create them. Each relation is themselves a stage 1 upres character with their own schedule and their own persistence. We add metadata, which is a bunch of extra fields based upon their profile. We add their recruitment mission. These missions too, they can create additional characters to populate the mission. And overall, stage 2 is computationally expensive. So one stage 2 upres can add as many as 10 stage 1 upres characters. So deferring all of this expensive stuff until stage 2, the final stage, is essential because we can wait until the player has expressed a clear interest before we do all the heavy lifting to generate their full story. So upresing as a concept was really successful. First off, as a technical solution, it worked well because it allowed us a really clean way to manage performance and decide when we were going to do expensive operations. However, it actually ended up being a really useful standby just for communication. Oftentimes we talk about features and say, oh, we need this for this feature to work. Okay, well, that doesn't happen until stage 2. Can we move that piece into stage 1? Can we add this feature? Oh no, we're looking at stage 0 people here and so on. So it became sort of a way to communicate. In fact, originally upresing was all or nothing. So having these stages allowed us to kind of not just manage the performance, but give us that communication win. Sometimes it constrained design, but it was never really a big problem. But we were usually able to either make subtle alterations to the feature or move things between stages so that we were able to proceed. And then just as an additional note, the operations manager was essential. We would not have been able to network Census without it. So it was really, really key. And with that, I will throw it back to Liz.
All right. So during the Upres process, there's a few different subsystems that come online that require a bunch of data and add a lot of detail that helps flesh out these characters from a player's point of view. And the first one I want to cover real quick is metadata. So these are facts that we justify as being data bought and sold, scraped by CTOS. It's sort of a way for the player to peek in on these characters as an extra incentive for players to get to know the characters prior to recruiting them and whether or not they actually do want to recruit them. And there's a few different design goals we had with this set of facts. So the first one was just to reinforce existing census data. So if we see a lawyer and we profile them, there's all kinds of possible facts for people with a background in law. If we see an Albion soldier, you might get a sense about why they joined Albion, what they like or don't like about their job. If you find someone like her, she has a low income, so we'll get lines nodding to that. And again, what we're really looking at are clear pieces of census data that like an occupation or an income and just reinforce them to make it feel like that is part of their character in more than just a piece of data on the board. And then next we want to look at revealing hidden census data. So this is data that we use to generate a character that is not visible to the player, either because it's never really visible to the player, but it's just part of the data used to make this a whole consistent character, or it's just not visible because we're not representing it right now. So for example, someone's orientation is not always observable in game. Maybe they're married or dating, but not always. So again, we use this space to try to bring up some visibility to those properties if they're being hidden from the player. Next, we try to draw complex connections across fields. So we can tag up any one of these narrative entries with as many constraints as we want for their occupation, their fashion, their gender, whatever set we want to do. And then when we generate a person and they match a narrow set of these tags, we can pull upon facts that are much more hand-tailored and much more specific to them. And this is where we can start capturing those concepts like high class that we skipped earlier by sampling fashion and income together. And in this case, she frequently purchases rock climbing gear because we've kind of slotted her into this subculture of athletic and sporty people, which is informed by the various set of census tags that she's been generated with. And then another thing that we tried to do was fill in gaps for representation. So there's just some data that we don't model within our system. So for example, everyone in our game, in our census data is either male or female to help simplify animation and voice pipelines. So we use this area to do things like representing marginalized genders. We also don't really represent physical disabilities much in the game, except for like our low mobility animation style. So we try to do whatever we can to add nods to invisible disabilities and make sure that they are at least referenced here. And this is our way of using this space to bridge those gaps whenever possible, if our systems aren't able to fully represent a person's whole identity. And then another part of another subsystem that comes online during the Upres process are our abilities or traits. And these are mainly the purview of our gameplay designers. And the role on the census team was trying to assign these abilities out to characters in a way that made sense, that was consistent to the character, and that followed this sort of main design philosophy of what you see is what you get. And in this case, what the player is seeing are two people exercising in the park. And just like we try to enforce the fact that their activity is exercising, on the ability side, we try to make sure, okay, let's make them physically fit. If the player runs across a character that's playing the guitar in the street, there's maybe not an expectation, but maybe a bit of a hope, and definitely sort of like a fantasy of the system that if we can, we should be able to recruit that character and then play guitar. And then on the design side, we want to fulfill that ideal fantasy as much as possible. And then if the player runs across an enemy AI that holds a gun and they're kitted out with this whole gear, there's this expectation that if you were to recruit them, they would come with stuff relevant to the gear that you see on them in the game and the abilities that they showcase. And what we call this is a character's affordances. So the higher the affordance, the tighter the mapping of abilities. And a high affordance character are just characters that the character and what the player sees about that character have a very, very tight mapping to what a player may expect out of their abilities. So for example, we have characters like the spy and the busker and the lawyer and the athlete, and they have a very high level of affordance. If I see someone doing something athletic, or I see a profile of somebody and I find out they're a spy, there's a certain expectation I have as a player of how that's reflected in their abilities. And so, for example, we have abilities related to getting the player out of jail faster. So if we have a lawyer, we want to make sure that every single lawyer in our game has an ability related to getting the player out of jail faster, which locks down at least one of their ability slots and narrows down the pool of possible abilities related that a lawyer could get. But on the flip side, we have really low affordance characters. So these are characters where they're basically kind of a blank slate. So someone who's unemployed, they have a really wide range of abilities we can give them on spawn. We can assign them abilities as though they're a former hacker or a musician or military or nothing at all, so long as, again, we are consistent with the rest of the pieces of the profile, with their schedule, with their character data. All those pieces line up, and we never contradict ourselves when we're giving these characters some of these blank slate abilities. And then I'm going to pass it over to Chris.
Yeah, so the last big section is on affinity and memories. So within the game, in sort of this big open world game, we actually have a lot of interactions that you can do, right? There's many, many ways that you can interact with that. And how do we begin to capture this? Well, at the core is what we call affinity. So affinity sort of is a running tally of how that character feels about DedSec and by extension the player. As you perform actions that impact those characters, it's going to affect their affinity. It'll increase it or decrease it. So it'll tell you if you manage to get them up to full affinity, well, they might be ready to join DedSec. They'll become a recruit. If you get them down to 0 affinity, then they'll oppose DedSec, and they might even take revenge. But as a concept, affinity is fairly abstract. So the next step is to actually tie it with something that's player facing. So to do this, we brought in character memories. So character memories are really simple but powerful, right? So I punch a guy, well, they're going to form a memory that your current DedSec operative punched them. Here we can see there's this guy running away because he was just assaulted by the operative. So it's really, really simple. When they get that memory, their affinity goes down. If you do a bunch of things like this to the person, their affinity may bottom out. If you manage to help them, their affinity is going to go up. So with the persistent entity system already in place, with these people, roaming around on their schedules, adding these memories and making them persistent is relatively cheap, and it actually ends up being a really high return on investment. But the big advantage here now is that every time you modify someone's affinity, there's always a character memory that goes along with it. So affinity is now a concrete player-facing thing that tells the player, I just did this action. Now I can see exactly how it affected this person. But then we can take it a step further. And we do this by actually adding character memory reactions. So here we have a person, the operative just injured their friend. Well, now their memory reaction means that this guy's now capable of, flipping you the bird, running away, or even attacking you. So they actually take action based upon these memories. It's not just a line of text. It turns into some concrete difference in gameplay. And then furthermore, we try to make this realistic by actually having memories propagate across relations. So if you help out a person, yeah, they'll like you more, they'll gain affinity, but so will their relations, right? Their friends will like you more, their family will like you more. And in fact, we can even be pretty complex with this. If someone has a rival and you negatively impact their rival, well, that person is going to appreciate that you messed with their rival, and they're actually going to like you more because of it. So now we have the system that sort of captures all of the different actions that you can do in this big open world game, and then ties it into a system that's easy to understand and that communicates to the player exactly how every character feels about it and gets reinforced by those characters' actions in the world. And then just to kind of close the loop, the most exciting thing about this is actually seeing these actions in the world, right? Seeing the impact of your choices as a player. So we reinforce this by what we call recasting. So this is where we take existing characters and place them into new and interesting situations. So a drug dealer that you previously met, well, they might become a drug dealer in a new mission that you've just started. And in fact, if that drug dealer has a memory about you or about your current operative, then the stage is set for some interesting emergent gameplay. The person you were helping, well, they might get cast into a world event where they're being mugged, and now suddenly you have a chance to save them, and you have to decide on the spot how you're going to deal with this situation, right? And now we have this tool that provides recruitment opportunities and allows you to sort of have these alternate paths to get people to join your team. So recasting, again, it's very simple, but it's a powerful feature, and it only works because of this really strong simulation layer and consistent characters with schedules and profiles. And now I'll throw it back to Liz.
Right, so we've covered all the main parts of the census system, and what I'm going to do is quickly run you through a character where we've put most of this detail on display in sort of a walkthrough. So it starts with a person who has spawned into the world. They're a blank slate. The only information we have are some basic visible properties that you can see. So this is called stage 0 Upres. Next, and so we can find their gender, their ethnicity, their age range, their fashion, their animation style. Next, when the player profiles them and locks onto them, we deliver the player the next stage of Upres, and we refine the profile to fill in the missing data. So this is where we get some of the information, like if they haven't spoken yet, we assign them a voice. They get a personality, so that if I insult them, we know how he's going to react. He has an income, so on and so forth. We give him a name. His name is Gareth Copper, which lines to his birthplace. Since he wears cyberpunk fashion style, we give him an occupation that sort of fits that constraint and end up with a network architect. We're also defining the character's abilities. So in this case, it's, again, fairly straightforward. He has 2 hacking related abilities. Both come from the fact that he works in occupationgroup.tech, which is because he's occupation.network architect, which is because he's fashion.cyberpunk. So you can see how all these different fields start influencing one another step by step to make this character consistent. And next, the player saves them to their recruits. And while the team map is loading, we start to get that next stage of Upres, and the system layers in our next set of data. So now we know he's age range that young, so we give him a very specific age. He has a high income, so we give him a high salary, but we give him a specific string for that. We also give him associates that form his relationships. So he has a blackmailer because we gave him something called identity.victim, which is sort of our way of assigning people into these roles consistently. He also has a therapist, which is a good example of a relationship that anybody can have in our game and there's no constraints with. Next, we look at the metadata and we fill that in. So he has a PhD in computer science because he's a network architect. He collects kaiju figurines because he's young and he wears cyberpunk clothes. He's a recovering meth addict because he has a relationship with a therapist. We also set his affinity, which in this case is positive to DedSec. And here's where we have a string we call the initial memory, which is kind of our narrative justification or our narrative alibi for why he likes DedSec in the first place. And next we can look at his schedule because now that's been generated. So some of this is fairly straightforward. He has a high income, so his housing where he goes to sleep is going to be in a high income, either neighborhood or at least like a housing, a building for that. He's a network architect, so he works in an office. He hangs out at Brokatech, which is our fictional futurist transhumanist corporation. And then that's because he's a cyberpunk and he likes doing that sort of thing. And then next we look at his different relationships are shown here too. So he goes to rehab with his therapist, but we also know the location of his blackmailer. And so this allows us to, as a player, be able to interact with the pieces of Gareth and potentially set him on a path towards recruitment or to eventually resent or hate DedSec, up to the player's choice. And then this last step is obviously informed by all of those steps that we made and choices we made with his character profile data, all his metadata, his schedule, all these things now wrap up together in a consistent way. So just as a wrap up, to close off the talk, Census is a powerful system used for generating characters that feel real and internally consistent. Through character persistent and schedules, these generated characters can be meaningful participants in the world instead of just background characters. The affinity system and memories tie the characters to player actions at a deep level. So now the player can interact with these characters and there's consequences to those actions. And then upresing allows us to effectively manage both performance and increasing feature complexity as we move toward ship. And so that is our whole talk in a nutshell, what we were able to fit in within an hour. Thank you for listening.
Thank you, everyone.